Hey, what's up guys, my name is Cherno and welcome to another Sparky devlog. So, this is devlog number 7 and I have been very hard at work over the last week and so many things have changed. Unfortunately, well, this isn't really unfortunate, but all of the things that have changed have been kind of internal under the hood changes. So like if I were to run this right now, you would see that basically it's kind of looking exactly the same, right? In fact, I think it's looking pretty much exactly the same as it was. In fact, let me just quickly, just to add to the effect, I've even got that whole set gloss value thing. I might just get rid of it, in fact, just for the dagger, the thing that I was showing you guys last time. I don't think I've got it anywhere else though. So I think the dagger should now be fairly glossy. Yeah. Anyway, yeah, you can kind of see that not much has changed. It kind of looks the same. However, oh man, so much has changed. And I'm going to kind of go through what I've done under the hood because there are a lot of changes. And kind of probably what I'm going to do over the next week as well. So, first of all, there are a few kind of user things that have changed as well. Like if you were to look at test 3D, you would see things that have changed. One thing I have to note, one thing I have to say really quickly as well is that the code right now, the code for Sparky, by the way, is always free and it's available on GitHub, and that is on github.com/thecherno/Sparky, right? This is the repository. However, it is a bit old now. It's like 2 months old. I plan to do an actual push for this in about a week. So as soon as I finish the stuff that I'm currently working on, I'm going to push it all to GitHub. However, if you do want the code right now, or if you generally just want to have the code as soon as I type it pretty much, then you can support me on Patreon, where if you pledge $5 or more per month, you will get access to a special versioner repository, and versioner is a version control system, a special versioner repository with pretty much all my latest commits, right? Again, I'm never going to keep code from you guys. Everything will eventually be available on GitHub, but if you want to have it sooner, then you have the option of supporting me. Again, completely optional. And I definitely don't expect you guys to do it if you don't want to, but it is an option that you have available to you. Okay, so, and that also greatly helps me out with developing Sparky. Okay, so we'll get onto the stuff that's kind of changed. So API-wise, a lot of things have changed. There are, like, gone are the days of creating engine kind of things, right? So like assets, for example, by creating them by simply going new blah blah blah, right? So if we try, I'm trying to find a good example here. I guess all of these textures are a great example. It almost doesn't look like they're any different, but basically you now no longer have the ability to say texture 2D text equals new texture 2D. Okay, that's not something that you have available to you. All right. The reason is that the big thing that I've been working on, as you know from last devlog, is DirectX, right? I've been putting Direct 3D into the engine, and I'm actually still going with that. It's not 100% done. You can see that OpenGL does work, because this is actually using OpenGL right now to render everything. But the big thing is that Sparky will be supporting multiple rendering APIs. So we'll begin with Direct 3D because I need to get that down so that I can start making tools for Windows. And then after that, we'll probably put in Vulkan. So anyway, because it supports multiple APIs, we have this huge kind of situation where we need to choose which one we want to use. Now, I'll kind of give you a high-level overview of how this all works because it would take an hour for me to actually explain it. But basically, the idea is that client side, and by client I mean game side, you can specify an API when you create the application by basically just putting it here, right? So I can change that to Direct 3D. It's going to crash if I run it. There's no way this is going to work. In fact, there it is right now. In fact, it failed like application verification. That's how bad this is. But anyway, it didn't get very far at all, actually. I expected it to get a lot further. But The idea is you can choose a rendering API here, which is, as you can see, something that you can do at runtime. And eventually there's probably going to be nothing that will really stop you from being able to recreate a context with another rendering API. So it might, you could even have this as an in-game option to change the renderer into something else, and that will just, of course, probably it'll have to destroy the window and rebuild a new one with a new context. So that's how you choose that. So what happens behind the scenes is when you do choose an actual context, and I'm trying to find exactly where this is. So okay, yeah. So application, I think, will be in Win32 application. Yep. So we'll set the rendering API, which is basically something that you set on the context, which is a static render API, and you can see we have the options up here, okay? And then all that's really used, you can see that apart from context being something that will actually be dependent on the rendering API choose, like the only reason this thing is here, this render API, is so that we can basically get it, right? And we can simply get the rendering API so that we can see which one we're using. So how does that happen? Well, the way that that gets used and the way that that works, a good example is to take a look at Win32 window, for example. When it actually creates the window, which is going to be the same regardless of the API used, you come down to this. Graphics API context, create. Okay, so this is going to create a context with these things. However, when you go into context create, right, into the implementation, there is a switch. Okay, basically we'll get the render API, and dependent on which one, we'll set the context to a subclass of this class, right? So for example, for OpenGL, we will set it to GL context, which is actually pretty brief here. In the case of Direct3D, if I can even find this, how did I close that? Here it is. If we go to Direct3D, you can see that first of all, it's a subclass of that with all the kind of properties that we need here. And then, you know, we have a bunch of initialization code here. So that's kind of the idea, and everything works like that. Like if I was to go into something like texture, texture is a good hierarchy because it's actually pretty complex. We have the base texture class, which first of all, these are just kind of inputs and parameters and stuff. And actually this stuff should be SP API. So that we can use them game side as well. But anyway, this is, as you can see, all these things are implemented as interfaces. They have no fields. They have no members at all. They can have static things, obviously, that's completely different. But they cannot have members. And they don't have methods either. They don't have member methods, right? They can have like static functions or whatever, that's fine. But methods, no, right? All of them are pure virtual, right? So it's just a pure interface. Then we have something like Texture 2D, which again is a platform specific. It's a platform in specific, so it's platform independent, right? Class which just adds some things that Texture 2Ds will typically do. So it's got a bunch of create functions so that we can actually create it, and then it's got you know, useful stuff like get width, get height, set data. You can expand this list, of course. Like it is something that will be expanded as time goes on. And then finally, from that, so this is just an interface, you have concrete implementations. You have either GL Texture 2D or you have DX Texture 2D, which is actually called D3D. I don't know, all the files, if we look at all the files here, all the DirectX files start with DX, even though the class names start with D3D. So I probably should change the files to D3D. And then we have all the OpenGL specific things as well. And then of course over here we have the actual like constructors, which if I call, you know, Texture 2D create, it will create it with the appropriate constructor. Actually, there's a bug right there. That should take in that. And from then on, yeah, that's essentially how it works. And then of course it will go into the constructor here, and that has all the fields that it needs, like the handle and all of that stuff. And of course it will even convert formats from like Sparky texture formats to OpenGL texture formats, and set up all that stuff. And you know, DX texture will kind of do the same thing, but in terms of DirectX, right? Cool. So that's how that cookie crumbles. It's all pretty simple. It's a nightmare to maintain though. Like to set up, it is very difficult, especially because Sparky was more or less kind of complete from the rendering API side. Definitely not fully complete, but on its way, definitely. And then, you know, stuff like vertex buffers kind of work the same way, where we have like a vertex buffer, which really just has like, again, an independent buffer usage, it's just an interface. And then from there, we have the create function, which is a static function, which returns a pointer to vertex buffer, and which one it chooses is based on the rendering API. And of course, it will then give you a pointer back to something like this, and you have those conversions here. And that is, for example, how a vertex buffer works. And then we have the same thing for like an index buffer. It'll switch and create like a DirectX one, for example, here. And we have all that stuff kind of set up, right? So it's huge. You can see how many files there are here. Like these are all like platform specific ones, and I haven't even finished either. The biggest one by far is the shaders. Do not get me started on that. That was a nightmare. Because remember, I am doing like shader parsing stuff, so I have to sort all that stuff out, and they work very differently. So I am making OpenGL work a lot like DirectX, which is a good thing, because yeah, it's generally a good idea to do that. So yeah, if we do take a look at like a shader, you can see that's GL shader. You can see how big this interface is. It's got quite a lot of things, right? So let's kind of go through this. I think I'll cover this, and that'll probably be it for this devlog. So if we take a look at the code here, basically we've got bind and unbind, of course, and then we have all these things, and these are pretty full on, right? So we've got set VS system uniform buffer. Okay, so that stands for set vertex shader system uniform buffer. So these are system uniforms, meaning they're set by the renderer. So they're uniforms set by the renderer. And these are ones that are in the vertex shader. Again, in OpenGL, it doesn't matter where the uniform is, right? It can be in the vertex shader, it can be in the fragment shader, it doesn't matter, right? When you set a uniform, you don't have to specify which shader it goes to. In Direct3D, 11 at least, you do have to do that, right? You have to be like, I want to set this uniform onto, you know, the vertex shader. So that's important. So now I've obviously made OpenGL work like that as well. And then we have set PS, a system uniform buffer, so set pixel shader uniform buffer again. Pixel shader is the same as the fragment shader. And then we have user uniforms. So we have system uniforms and we have user uniforms. And user uniforms are things that are set by the material, right? And by the actual kind of appearance, right? The material of the thing that you're rendering rather than the actual renderer. So an example of a system uniform would be like the camera, right? And an example of a user uniform would be like the color or a texture. Actually, coming to textures, there are also resources, right? So textures are basically resources. Man, this is actually so much work. This took me so long. Anyway, so we have all this stuff. And then we can of course retrieve them and get whatever. So if we look at one implementation of a shader, let's take a look at GL shader. You can see that this is a pretty big class. So what we have here are all of the kind of things that we need. So we have these are system uniforms, because they really should call them system uniform buffers. We have user uniform buffers, which are user uniform buffer declarations. So apart from having this, of course, you also have the whole shader uniform thing class, which has a bunch of, like, this has like 3 classes. It's got like shader uniform declaration, shader uniform buffer declaration, shader struct, and that's it. And then you have GL shader uniform, which has implementations of those. So we have GL shader uniform buffer declaration, and field is actually not used anymore. And then we've got GL shader uniform declaration as well, which does all that stuff. And you can see that there is a lot of stuff that happens here. And I would get into this, but again, that's something that I can probably save for another video. And then so eventually what happens is when you decide, and look at, like, this is a huge 730 lines here. A lot of shader stuff going on here. So we compile basically, and eventually we come to the probably meatiest solution of this entire kind of thing. And that's the parsing, right? So what is that? Oh, right. Okay. So I need to talk about that as well. So in DirectX, we have these things called constant buffers, and that's essentially kind of the same as uniforms, right? So in OpenGL, you're probably familiar with going through every uniform and setting it one by one. Of course, like modern implementations of OpenGL or modern versions of OpenGL do support uniform buffer objects, but that's something different that Sparky currently doesn't support. It will in the future for sure. That being said, we also have to say that OpenGL, so currently we don't support that, right? DirectX, though, that's basically the only way that it works, or at least DirectX 11. So because of that, I've made OpenGL always support that. This will be good because when we do support uniform buffer objects, it'll be a lot easier to implement. So everything gets put into a buffer, quote unquote, and that one's just called global for now. One for the vertex shader in this case, one for the fragment shader. We pass all of these different things, right? So uniforms, and then we if it's a struct, we pass that. If it starts with underscore, with sys underscore, it means it's you have to use that naming convention. It means it'll be put into the system uniforms. Basically, you can see that we put it into the uniform buffers instead of the user uniform buffers. And oh man, sorry, this is just so fresh on me that I really don't. I've spent like a week on this, so I really kind of don't even want to talk about it right now. But I will make some kind of follow-up video when this is kind of cooled down a bit. Then we have uniform structs. And so eventually what will happen is when we resolve uniforms, these are when we actually retrieve locations for them. We don't need this anymore. For structs, for example, we have to retrieve them using the, name dot field name, and that's how you get the location for them. And we fill all that out. Then we go through the resources. This is worth noting. If while we're passing a uniform, we detect that it is a resource, right? Which right now just means it's either a sampler 2D, sampler cube, or a sampler 2D shadow. If we detect that it's a resource, well, first of all, we add it to, let's see where we are. First of all, we add it to the resources, right? And this is a shader resource declaration, which is a little bit different than a shader kind of thing, than a normal uniform. And the reason it's different is because DirectX actually does separate them, but as it should really be, because they are very different things. And so what we do is when we're resolving uniforms, over here, what we actually do is we go through, we grab the location, of course, of the sampler in GLSL, and we straight away, we just set it. Okay, and they are set in chronological order. Again, it does not matter what they get set to. We also set sampler arrays here as well. So for example, the batch renderer, which uses the default shader, has an array of sampler 2Ds. It's got 32 of them, in fact. So it sets them all the way 0 through 31. Okay, and this just gets set basically at shader creation time and does not get touched from then on. Now, the resource declaration is aware of what slot it's bound to. It knows what the sampler index is, right? So, for example, the fifth sampler that appears in our shader will be, slot 4, basically. So, if we're on that slot, what happens is, since it is a shader resource declaration which has a name, and it knows which slot it's in, when we actually do set it, we know which GL active texture we need to set it to, because we say, hang on, which uniform are you trying to set this texture to? Let's get the resource declaration and let's get the slot for that. And then we set it. It's kind of complicated, but it works very well. And it means that we never have to worry about setting uniforms for samplers and for textures ever again. We just set textures now, which is how it should be. And then, yeah, I mean, there's a lot of stuff here as well that kind of works. And then we have, of course, the base kind of OpenGL ones, which really should be surrounded by GL core, but there we have them. All right, and then that links very closely with materials. Now, there are two new things. There's PBR material, which extends material, or subclass of material, which just has some useful functions. That's all. You can see it doesn't actually have any fields at all. It's just got, these aren't used anymore either. They're old school. I'll delete them. So you can see that, for example, for setting albedo, it sets using albedo map to 0, because we're using a color and not a thing. Again, a lot of stuff to explain. Oh man. All right. So, and then we do the albedo color, and we do all this stuff. It basically just helps us with setting stuff. That's all. But the way that in materials, the way that we set uniforms, again, is really simple. We just simply have to call we just simply have to call set uniform, right? Or set texture. So set texture is probably a little bit more exciting. When you set a texture, you have to set it to a uniform straight away, right? So if I've got something, let's look at the PBR shader. If I've got something called, in my PBR shader, if I've got something called U environment map, which is a sampler cube, right? I have to say set texture, U environment map, whatever texture, right? And then what that will do is it'll find the declaration for the resource. So it knows which slot it's in, or which register it's in. Register, slot, same thing, right? In DirectX, they're called registers. And then what happens is, well, we add it to that correct slot in a vector. So now we have that slot, and then when it's time to actually bind the material, it will go through all the textures and bind them to the appropriate slot that they're in. So, scenario, we have that sampler. As I said, the sampler uniform gets set to 4, which means that it gets set to textures, since the slot that we're using is a register. It gets set to index 4 in the textures array. So when we're iterating over it to bind it, we of course go to I equals 4, and we bind the texture, which, if it's a texture 2D, for example, it doesn't actually matter. They all kind of work the same. Sorry, GL texture 2D. Then it sets GL active texture equal to 0 plus slot, right? So it'll set it to GL texture 4. And there we have it. So it's all automatic, which is lovely, because having to do that manually is absolutely awful. And that's kind of it, right? There's so much more stuff. Another big thing that I did was, before fonts I used to let FreeTypeGL create the font texture. Now it doesn't do that. I'm still using FreeTypeGL to properly lay out the atlas from FreeType. And then what happens is I simply create a texture and I set the data to that atlas data, and that's all I'm doing, right? So I'm kind of, it's like the code that used to be in the atlas at the very bottom that does this stuff, this now doesn't do anything. In fact, this should really return. I kind of forgot to mention that. Or like this code really just doesn't need to exist anymore. That's what it used to do. Now it's properly handled by Sparky. All we do is we mark it as dirty as well, which means that's another thing that I added actually to FreeTypeGL here, to the texture atlas, so that basically when more glyphs get added to that texture, it will update the atlas, right? Which will basically just reset the data, which will just be called GL text subimage 2D and reset the data again. Anyway, yeah, so that way fonts work now without having to, without that system, which is important because obviously FreeTypeGL, I still want to actually use FreeTypeGL for DirectX, so that'll be fun. Again, all I really need FreeTypeGL for is to generate that texture for me. I don't need it to upload it to OpenGL or anything like that. It just needs to generate those pixels for me. That's all I want from it. All right, cool. And you can see obviously my font rendering is still working, even though wow, that's crazy. Even though I'm not using FreeTypeGL for that. Okay, cool. So anyway, that is the way that works. The other thing that I quickly added, which I haven't actually, I've begun to kind of add it, but I haven't yet, which you might have noticed if you look at really anything that allocates memory, is SP new, right? So instead of using the C++ new, that's actually an overload, there's SP new, which is a macro. So I've created a file called memory.h, which is in system for now. And basically all that does is, well, the macro just kind of also inserts file and line so we know where the allocations are coming from. But right now, again, they're really, really simple. I've overloaded operator new and delete, by the way, which just means that I can do custom allocation stuff. Right now, again, they're just returning malloc with size. They're just there so that I can kind of debug better, right? So if I have really large allocations, for example, with this, I can assert. So this is very common where when you try to, for example, create a new array with an uninitialized variable as the size, and it's set to like 4 billion. Then of course this will immediately assert, and you can be like, all right, instead of maybe working somewhat and then failing later and being hard to debug. So that's nice. But eventually, of course, Sparky will support custom allocators. At least we'll be, in debug mode, for example, we'll always verify that the heap is not corrupt anytime we allocate more memory. And there's all this kind of debug stuff that we can do with this, as well as add custom allocators to speed up performance, like a lot, right? Anyway, so I've kind of started working on more system stuff. I'm still kind of working on graphics though, and I obviously, now that I'm doing DirectX, that's very important. But yeah, I mean, I was looking at this the other day, and Sparky is actually becoming a really big project. If we look at source, so this is in Sparky core, this is all code that I have personally written. So this isn't like dependencies or anything. If we actually take a look at the properties, 244 files, right? So this is not a small project anymore, and I was well reminded of that when I tried to, again, put in DirectX. And it's also like, one other thing I wanted to mention was that the batch renderer and stuff is becoming very kind of platform independent as well. You can see we just do index buffer create, for example, vertex array create. Vertex array is just a collection of vertex buffers. That's all it is. It doesn't actually use, oh, that's the other thing. OpenGL no longer uses vertex arrays. This will create a GL vertex array, which doesn't actually create an OpenGL vertex array. Yeah, there's no such thing as that anymore. We're not using vertex arrays, only vertex buffers. Which basically just means that, for example, oops, that's DirectX. Why didn't I click on that? Which means that like the layout for the buffer has to get reset every time we bind it, which is a bit annoying. But anyway, again, that's a choice I've made. That's not by necessity. That we're not using vertex arrays anymore. Still some things to iron out here, but it does kind of work. So yeah, anyway, that's pretty much it, guys. I hope you enjoyed this video. I hope you saw the cool stuff that I'm doing, and I hope you learned a little bit at least. Yeah, I mean, just so much work. So much work. All right, cool. So thanks for watching. If you did enjoy Sparky, then please support it on Patreon. The link will be in the description there, and if you'd like, of course. I should be coming out with some more videos. I've had a lot of requests from you guys to make some like an OpenGL series, and I think I will probably start like pre-production on that in the next few weeks. So I'll start thinking about it, and I'll start jotting down some ideas and formatting it a bit, and hopefully it should come out maybe in a month or so. And we can start kind of working on that. So I'm really excited to do that as well, because I want to get back into making tutorials for you guys. But I think I've covered pretty much all that there is to cover. Yeah, so if you enjoyed the video, please hit the like button, and I'll see you guys next time. Goodbye.